All right, so when you're working through, again, you see base e, base 5. There's no way to express those using an exponent with the same base. So take the log of both sides, in this case the natural log ln of e to the x, ln of 5 to the 3x plus 4. Right, and so by doing this, you can bring your powers out front. And ln e, when we get x ln of e, when you have an input that's the same as your base, that has an overall value of 1. Okay? So this is just going to cancel, just be a 1. Again, it doesn't disappear. It becomes a multiplying by 1 identity. The 3x plus 4 comes out front, ln 5. And now we still have an x term, so we need to distribute the ln 5 here. So we get 3x ln 5 plus 4 ln 5. Move the x terms together. So if I subtract 3x ln 5 from both sides. Now, when I remove my common factor x, there's still got to be 2 terms left here. So removing an x from an x leaves a 1. From the next term, again, I take the x out. And now divide by that binomial. Okay, so if you were being asked to give the exact answer, this would be your solution. And if you were asked to give a decimal equivalent, okay, if you took 4 ln of 5, divide by the entire quantity, 1 minus 3 ln of 5, close off the denominator, and I'd get my answer negative 1.6816. And now, all right, when you look at these next 2 examples, okay, if you see your bases can't be rewritten, so you start to take the natural or the log of both sides. So if you started the ln of negative e to the x, and notice again, can you have a negative in the input of a log? No. So you know that this is going to be does not exist. The only thing that you need to be aware of is if both sides happen to be a negative, you would multiply both sides by negative, it would cancel out. And so what about this last example here? When you start to take the ln of both sides, is it going to work? No. So you can stop right there, and that's not going to be a solution either.